Okay, so we are now in alkalimetry, a little review class. Do not forget how when you say alkalimetry, our sample here is an acid and our titrant is a base. Okay? Kasi pagdating sa acidimetry, that's the other way around. So for acidimetry, the sample is a base and then the titrant is an acid. But just like acidimetry, we can also do direct titration and even indirect titration. So when you say direct titration, you will have one titrant only to be used in the titration process. Okay, one titrant only. So you have one sample and one titrant. But when you say indirect titration, or we also call that residual titration, you have one sample also, but this time you have two titrants. Okay, so for the two titrants, the first titrant will be added in excess, and then the second titrant will be used to titrate the excess or the excessive na first titrant. Okay, so we do that for some reasons, like we cannot have a sharp endpoint when we do direct titration, or the reaction will proceed slowly. Okay, or if the direct titration is not possible because there is a problem with like solubility of the samples. Okay, so we are done with these two problems here. Your assignment is this one. A 4.0520 gram sample of hydrochloric acid whose density is 1.18 grams per ml required 44.15 ml of 0.9035 normal sodium hydroxide in a titration. So calculate the following. First, hydrochloric acid content in percent weight per weight. So we are talking about percent purity here. What was your answer? Let me see. Can you send sa chat box? What's your answer for letter A? This is for letter A. Percent purity is equal to N times V times milli-equivalent weight divided by the weight of sample. This is for the weight of sample times 100. So this is just class A direct titration since we only have one titrant here, and that is the sodium hydroxide. So this is an example of alkalimetry since our sample here is an acid, that's hydrochloric acid. And our titrant is a basic substance. So let us identify what is asked in the problem is the percent purity, weight per weight, and then normality is given. Yes, this is given. So let me substitute this one, 0.9T35, and then let me just use MEQ per ml so that we can properly cancel the units. And then for the volume used during titration, that's 44.15 ml times the milli-equivalent weight. So that is not given in the problem. But the weight of the sample is given. That's 0.4 T. Ay, baliktad. Anong 0.4 pa rin? 4. 4.0520 grams. Again, we will be looking for the milli-equivalent weight. Class, kung ano yung sample, yun yung hahanapan natin ng milli-equivalent weight ha. So our sample is hydrochloric acid. So before we can compute the milli-equivalent weight, we have to first find the molar mass. This is one atom each element times their respective atomic weights. So this is 1, this is 35. The molar mass of hydrochloric acid is 36 grams per mole. And for the milli-equivalent weight, our formula is molecular weight or the molar mass divided by F times 1,000. So this is 36 grams per mole And the F, since this one is an acid class, you will be just looking at the number of replaceable hydrogen. And for the case of hydrochloric acid, you only have one hydrogen here. So this is automatically 1. So this is 1 times 1,000. Our unit here is milli-equivalent per mole. Cancel the mole. Will be the answer. 36 divided by 1,000 is 0.036 grams per milli equivalent. So yan yung gagamitin natin for the milli equivalent weight. 0.036 grams per milli equivalent. And do not forget times 1,000. Okay, so let's do the math. 0.9035 times 44.15 times 0.036 is 1.4360229 divided by, let's cancel first the units. You can cancel the milli equivalent, the ml also, and also the grams. So divided by 4.0520 times 100. This is divided by 4.0520 times 100. Round off to 2 decimal places. The correct answer here is 35.44%. Okay, so this is the percent purity of the used hydrochloric acid as the sample. Bakit yun siya nag 7.78? What happened? Or did I miss something? Bakit hindi tayo magkaparehas ng answer? Bakit lahat kayo 7.78?
Ang gibuhat gud na mo ma'am kay katong percent is equals weight of solute over weight of solvent times 100. Kaya na mag-percent weight of weight po.
Percent weight. Did I mention about that kind of formula? Saan? So anong ginawa niyo? This one is the solute and this is the solvent here. Ayan yung ginawa niyo. Let me see.
Bali ang ano po ma'am, ang weight of solute namin kay CHCl po, tapos yung weight of solvent namin kay CmAOH po.
Oh, okay. But take note that titration was done here. Did you do titration in the laboratory? You are not making a solution here, ha? You are doing titration. So kung gumawa ka lang ng solution, kung yung 4.0520 gram sample, diniretso mo dissolve doon sa solvent na sodium hydroxide, hindi din kasi siya possible kasi magre-react yan silang dalawa. So you will be obtaining sodium chloride and water there. So hindi ko siya maisip bakit ganon. Ano ibig sabihin ng percent weight per weight dyan? Kasi remember, this one is milli equivalent weight and this is weight also. Kaya nilagyan dyan ng percent weight per weight. Okay? But that is still percent purity. Okay? Percent purity pa rin ito. We can actually add weight per weight here. Again, the weight per weight there is referring to the used milli equivalent weight over the weight of the sample itself. So again, the correct answer is 35.44. You only do that plus mag-solve kayo ng percent pag hinahanapan kayo ng concentration. Hindi yung percent purity, hindi yung, kasi may nakalagay dito HCl content. So hindi talaga ito naghahanap ng concentration. Hinahanap niya yung percent purity, yung content na HCl ng sample. Okay? So I hope that is clear. So when next time you are confronted with this kind of problem, you first understand the problem and then think kung ano ba yung hinahanap. Okay? So even though nakita nyo dyan may nakalagay percent weight per weight, take note, it is asking for the HCl content just in percent weight per weight. Okay, HCl content ang hinahanap, hindi yung direct concentration. Actually, this one is asking for the concentration, but ito yun, nasa baba. Normality of the hydrochloric acid. Yung nasa taas content yan. So, I don't know if I have mentioned that. When you say percent purity, hindi ko kasi maalala kung nag-mention ako. Like sa paracetamol, di ba? Like if we have paracetamol tablet, it doesn't mean it's just paracetamol there. Kasi you are done with your DDS, you are done with your manufacturing pharmacy, and you have learned that aside from the active ingredients, our dosage forms also contain a lot of pharmaceutical excipients. So if the problem is asking for the percent purity or for the percent or the content of something, ito yung ginagawa natin. Nagkakandak tayo ng titration. And our formula is this one. For direct titration, percent purity is equal to normality times volume times milliequivalent weight divided by weight of the sample. So kung diniretso siya, ano na yung saysay ng titration dyan? Pag diniretso niyo yan. Kasi na abi ninyo connect sa farm cancer. In a way, this one is still connected to farm cal. Yung QC kasi and yung pharmaceutical calculations, related man. Okay. Kasi sa question, hindi nag-ask ng percent purity. So, hindi naman talaga all of the time you will be the one who is going to make the question will use the term percent purity. So, pag sinabing percent purity, gaano karami yung certain active ingredient dyan sa chemical substance mo or sa sample mo or sa dosage formulation if this is a dosage formulation. So it may be called content of that certain substance. Yeah. For solutions, we are solving percent purity also. Oo. Pwede din. Pero we are going to do that using titration, ha? Magta-titrate tayo. So we are only discussing kasi acidimetry and alkalimetry kasi we are still under sa neutralization reaction. But after finishing the acidimetry and alkalimetry, we will be talking about precipitometry and compleximetry. So, titration processes pa rin yun, but that is outside acids and bases kasi. So, nakakoncentrate sa ito dire. Nalisang mo sa percent weight per weight and then you forgot the HCl content. Okay? HCl content ang hinahanap. Gaano karami yung hydrochloric acid in that certain sample. It's just that it is expressed in percent weight per weight. So 35.44% yung tamang answer dyan. Now how about letter B? What's your answer sa letter B? Ang ginawa niyo dito? Let me check. Before. Times 62 to 28. 4.0520. Forty-four times 0.9, 35, 11.62. Yeah, 11.62. We will be using C1V1 equals C2V2 here. Let me check. 11.62. Yeah, C1V1 equals C2V2. 17.72. That is for letter A. 3.50. Saan ang galing ng 3.50? Oh, wait. Okay. Sige. Ganito ha. Ang tandaan nyo, if during titration, primary standard is being used in the process, you use this formula class. Weight divided by ml times milli equivalent weight. Okay? Pero if during titration, ang ginamit is a secondary standard, you use C1V1 equals C2V2. C1V1 being the concentration and volume of the titrant, and then this is for the analyte or the sample. Okay? So yan yung kaibahan nila. I hope you can still remember the difference between primary standard and secondary standard. Pag primary standard class, we are using a solid substance during titration. So just like when you are going to assay sodium hydroxide, tapos gagamit ka ng potassium acid phthalate, that's a primary standard kasi potassium acid phthalate is a solid substance. Bale, mahuhulog na doon siya sa Erlenmeyer flask, and your supposedly sample, which is sodium hydroxide, will become a titrant. Kasi siya yung idadagdag using a burette. But during titration, gagamit ka ng secondary standard. So yung sample mo talaga nandoon siya sa Erlenmeyer flask, and then you are going to use another substance na liquid, this time liquid. So nandoon siya ngayon sa burette, siya yung magiging titrant. Secondary standard ang tawag doon. So ito yung gagamitin natin, C1V1 equals C2V2, though the sample there is in grams. Pero since density is given, you can look for the volume of the sample. Okay? So ang gagawin ninyo, remember density is equal to mass over volume. Density here is 1.18 grams per ml. The mass is 0.0520 grams. And then you are looking for the volume. Cross multiply, we will have 1.18 grams per ml times the volume equals 4.0520 grams. So divide both sides with the 1.18 grams per ml. Sorry, I'm not fond of deriving formula. I will always go back to the original one and substitute everything. That's how I compute class. So this is 1.18 grams per ml, cancel the grams. So the volume for the HCl here is 3.433898.305 ml. Okay, wait a minute ha, may nag-call. Let's continue. Sorry for the interruption. Wala. Ay, nahulog. Okay, so that's the ml. And then, we will be using C1V1 equals C2V2. C1, concentration of the titrant. That's 0.935 N. Okay, ito. Times the volume volume of the titrant is 44.15 ml equals the concentration of the sample. We are looking for this one, and then for its volume, we have computed that using the density. That's 3.433898305 ml. Okay, divide both sides with the 3.43389805, may 3 pa pala dyan, ml. And then let me just shortcut this one. Hindi tama nagsulat. Cancel the ml. So, ayun na. 0.9035 times 44.15 divided by 3.43. The normality, the concentration of the sample is 11.63 normal. Okay? That's the correct answer for letter B. Any question or clarification regarding this problem? Again, percent purity is the same as asking for the content of a certain sample. 11.63 kasi ang answer dito sa okay. I-shortcut ko din pala sa calculator ko. Ulit, 0.9035 times 44.15 divided by 3.433898 ng 305. 11.62 pala siya. 11.62. Okay. Sige, anything else? Wait lang ah. Please. Kasali ata ito sa assignment. Compute for the normality of HCl. Pero dito nakalagay using a secondary standard. So secondary standard ito. It's a liquid substance having a concentration of 2 normal. It consumed 35 ml of sodium hydroxide. The volume of sample used was 25 ml. So it's the same thing with the previous problem. Since this is using a secondary standard using titration, you will still be using this formula. C1V1, this is C1V1. C1V1 equals C2V2, and then the C1V1 is for the titrant or the secondary standard. So it says here that sodium hydroxide used was 2 normal. The volume that was consumed was 35 ml. And we are still looking for the second concentration or the concentration of the sample multiplied to the volume used, that's 25 ml. So divide both sides by 25 ml, 2.8. Again, let's see. So the C2 here, 2 times 3570 divided by 25. Yes, that's 2.8 normal. Okay? But that's how you do the computation of the normality if during titration, secondary standard is used. But again, if primary standard ang ginamit, you use our original formula for normality, which is weight of the substance divided by ml times milli-equivalent weight. Okay, I hope that is clear. Any question or clarification? May gusto bang itanong? Wale? Sure na? Kasi we will be moving on with the residual titration. So for the residual titration, again, you will still have acid as the sample here. Okay, since we are talking about alkalimetry, but we will have 2 titrants. The other one is a base that is added in excess, ina-add ito dito sa sample natin which is an acid. And then another titrant will be used which is a standard acid. Gagamitin siya to titrate the excess na base na inad doon sa ating sample. Okay? So, aside from, meron tayong formula last time, di ba, sa acidimetry. Percent purity is equal to N1 V1 and N1 times V1. N1 times V1 minus N2 times V2 times the milli-equivalent weight, again, times the milli-equivalent weight divided by the weight of the sample times 100. So the same formula with that of the residual titration or indirect titration for acidimetry. So malalaman mo naman kasi in the problem, you will really see two normalities and two volumes for the titrant. So I hope hindi kayo malito with that one. Baka malito kayo kung direct titration ba siya or residual titration. So residual again, dalawa yung ating titrant. But aside from the residual titration, we may also do blank titration. I think I have also defined this one last time that when you say blank titration, you will be repeating the titration process. So the same procedure sa pag-conduct ng titration, but this time you are going to omit the sample. Okay? I-omit yung sample. So if this is your burette here, this is your titrant here, you will be doing titration. You will still use the Erlenmeyer flask, but ang nakalagay lang dito ay si solvent. So most likely this one is water and yung indicator. Okay? Yun lang yung laman ng Erlenmeyer flask during titration if you're asked to do blank titration. So do not forget the indicator ha, kasi you will not have any change in color or you will not achieve the endpoint without that. So why are we going to do the blank titration? This is actually to omit bias or to just check whether the result of the titration process is correct or not. Okay? Kung may difference ba siya sa result if nag-titrate tayo na naandoon yung sample mo and nag-titrate tayo ng walang sample. Kasi baka after the titration process, you will get this same percent purity, which in fact, wala ngang sample yung sa blank titration. So, in the assay of aspirin class, ito yung formula na ginagamit for blank titration. Example lang ng ginagawa ng blank titration ha, the aspirin. The aspirin is a member of the NSAIDs, the non-steroidal anti-inflammatory drugs, though at lower dose, aspirin is used as an anti-platelet drug, but at higher dose, that's the time na magiging NSAID siya. Okay, so do not be confused. I don't know, hindi kayo nakapag-community pharmacy internship na on-site. So, hindi ko alam kung ano yung inyong like background with this one. Pero minsan kasi pag may nagtatanong para saan ang aspirin, pag hindi alam kasi yung sagot, most likely ang sinasagot is para sa high blood. Kasi partly true, binibigay talaga siya sa persons with hypertension, but it is not an anti-hypertensive drug ha. It's just that at lower dose, look at Aspilex EC, for the Aspilex itself, ang nakalagay doon na dose is just 80 milligrams, and that is anti-platelet. It will prevent the formation of clot. And we don't want that for persons with hypertension or even heart problems. Since they have a problem with the heart or with the flow of their blood, they are prone of like blood clots, or meron silang atherosclerotic plaque in their blood vessels that will trigger clotting and then clogging, and that will be the reason why hindi na makaflow ang blood, especially in the heart, and again that will trigger the heart attack. Okay, so again, at lower dose, aspirin is used as an antiplatelet. But at higher dose, most likely mga 100 milligrams or 300 milligrams, that's the time aspirin is used as a non-steroidal anti-inflammatory drug. Eh, basig na maglabad ang ulo din tapos niinom ang aspilet, wala na tabla, ni reklamo, dili gyud ka matablan ato kasi lower dose yun siya, antiplatelet lang yun. So sa QC na part, since we are dealing not just with the mechanism of actions or the indications, clinical applications of these medicines, we are also preparing them. So it's also very important for us to ensure that what we are producing are of good quality and talaga pure yung ating ginagamit in the production of these drugs. So again, for the assay of aspirin, if we want to know how pure our aspirin is, we do not only do direct titration or even indirect titration, we do blank titration. So if the process involves doing the blank titration, this is our formula. In the screen, percent purity is equal to the volume of the blank minus the volume of the sample times normality times milliequivalent weight divided by the weight of sample times 100. So actually it's the same. It's almost the same formula with that of the direct titration. It's just that dalawa yung volume natin dito. The volume during the titration with the sample and the volume of the titrant used during the blank titration. So let me give you a hypothetical result of the standardization process of our aspirin. So during the titration, 2.1 grams of the sample, this is for aspirin, was used. Okay, and then take note of this, ml of NaOH taken for sample and blank, this is 40 ml of 1.1 normal HCl required for blank titration, that's 41 ml, and ml of 1.1 normal hydrochloric acid required for sample titration, that is 31 ml. So basig nalibog mo ma'am daghan sa volume. Oy, class, ganito, ang assay ng aspirin is actually supposedly indirect titration. So if you have aspirin, this will be added with a titrant that is given in excess, and then that is the NaOH. So this is the first titrant. So in this case, the first titrant was added, and that is 40 ml. And then afterwards, you have the second titrant, and that is the hydrochloric acid. So again, supposedly this is an indirect titration. However, blank titration was done for aspirin. So we will be using this formula. V of the blank minus the volume of the sample times the normality times milliequivalent weight divided by the weight of the sample times 100. So ang volume class ng titrant na nagamit for blank titration was 41 ml minus the volume of the titrant nung merong sample is 31 ml times the normality of that titrant. We are talking about the second titrant here ha. For blank titration, we are not going to use the normality and the volume of the first titrant. So this is 1.1. Let me use class MEQ per ml. And then times the milli-equivalent weight. We are yet to compute for that. And then the weight of the sample used was 2.100 grams or just 2.1 times 100. So kaninong milli-equivalent weight yung hinahanap? Syempre sa sample, and our sample is aspirin. Now, hindi yan siya nakalagay sa problem. Are you done with the discussion of NSAIDs in your in either your PCOL or your farm chem? Let me know para kabalo ko kung sa'yo akong i-expect sa inyo since both subjects hindi ako yung teacher niyo, so hindi ko alam. Anyone? Are you done with the NSAIDs? Either in PCOL or in farm chem? Anesthetics pa mo sa PCOL. General and local. How about the farm chem? Farm chem 2. Wala din. Anong lesson yun sa farm chem 2 ngayon? Kasi farm chem 2 and PCOL are almost similar. It's just that you are dealing more on the structure and the functional groups present sa drugs sa farm chem 2. Teacher niyo si Eureka. Antimicrobial. Okay. So I hope nakinig kayo sa sinabi ko kanina sa aspirin ha. Just additional knowledge about aspirin. Aspirin class is abbreviated as ASA since its chemical formula is known as acetyl salicylic acid. Okay, acetyl salicylic acid. This is the chemical name of aspirin. Aspirin is the generic name. You know that? Diba? Our drugs have at least 3 names. The generic name, which is accepted internationally, the accepted name internationally for a drug. And then the brand name or the trade name, which is given by the manufacturer. And then the chemical name. So that is derived from the structure itself, from the functional groups present in the structure of the drug. So this is the chemical name of aspirin, acetyl salicylic acid. So again, sometimes it is abbreviated as ASA. So if you see ASA in area 4 in PCOL or in area 1 sa farm chem 2, that is referring to aspirin. Now let me draw the structure if I can remember it correctly. Structure of aspirin. Let me check. This is let me start with the salicylic acid. Salicylic acid is this one. And then, oh yeah, dito ang acetyl. Wait lang ha. I'm thinking. CH3 acetyl, dalawa. Let me check na lang din. I forgot. Acetyl is to carbon, so dapat dalawang carbon ito. May double bond ito dito. And then this is not CH. This is CH3 here. 1, 2, 3, 4. Let me check. May trust issue sa ako ang maalala sa acetyl salicylic acid. That's the structural formula. Tama yan. Yeah, it's correct. Hindi na po mali. Tama. Okay, so this is the structure of the aspirin, acetyl salicylic acid. Kaya sinabi ko kanina na I'll start with salicylic acid class kasi salicylic acid is this one. COOH here. And then this one is OH. Okay? So may OH siya dyan. Ito yung salicylic acid talaga used as under siya sa mga antifungal, but salicylic acid is a keratolytic. It will cause sloughing off of the skin. Okay? Ito yung acetyl salicylic acid and this is the aspirin. So bakit ko siya dinraw? Kasi kailangan ko yung kanyang chemical formula for the milli-equivalent weight. Ay, nanawag na sa ng finance ka. Jot lang. Sige. So remember MEQ. Milli-equivalent weight is molar mass divided by F times 1,000. So I need the molar mass of the aspirin. And the molecular formula of aspirin is C 1, 2, 3, 4, 5, 6, 7, 8, 9. C9H. Have one hydrogen here. 1, 2, 3, 4, 5, 8. That's 8. C9H8O 1, 2, 3, 4. Okay, so C9H8O4 yung ating molecular formula of aspirin. Okay? Paki-check din ha if nalibog mo paano na ko gi-count ang hydrogen sa aspirin. You try to make the full structure of this one. Okay? I believe you have that in your organic chemistry. So for the molar mass, this is C 9 times 12. It's 108. Hydrogen is 8 times 1. This is 8. And oxygen is 4 times 16. This is 64. Ano ba niya kung panghimo diri or basig na ako na-miss? Yeah, tama. Kasi 180 grams per mole. Okay, so this is now 180 grams per mole. Then what about the F? Okay lang kasi yung acid class no na kapag inorganic chemistry, madaling malaman kung ano yung F niya sa acid kasi bibilangin mo lang yung hydrogen. Pero kapag ka-drug na kasi talaga siya, it's a complicated structure. You just have to take note class na for acid, since this one is an acid, klaro kayo na sa iyang pangalan, that is still referring to the hydrogen, but take note, replaceable hydrogen. Okay? Replaceable hydrogen ni aspirin. Okay? Wait lang ha. Ano man good name? Wait. Sorry kayo sa kadaghang interruption sa world ha. Kajut lang. Kasi milli-equivalent weight of our aspirin. The F here class is 2. 2 times 1,000 milli-equivalent per mole. Paano yan siya naging 2? Though it is not really on the hydrogen ha. But actually kasali pa rin si hydrogen. This part kasi of the aspirin, itong OH niya na which is part of the COOH is included. Pwede niya kasing i-give up itong hydrogen dyan, and that is available for reaction. And then aside from that, this part here can also be given up, not really with the number of hydrogen, but parts of the structure class can be given up to have another reaction with the titrant. So all in all, dalawang parts yan ng aspirin na magre-react with the HCl. First with the sodium hydroxide. Kasi yung HCl dito na magre-react with the excess na sodium hydroxide. So please take note that our F for aspirin is 2. So 180 divided by 2,000 is 0.001. Asan ako magsulat? Dili na lang. 0.09 grams per milli equivalent. Yan, 0.09 grams per milli equivalent. And then, let's do the math. 41 ml minus 31, that's 10 ml times 1.1 MEQ per ml times 0.09 grams per milli equivalent. Wala na ko space. That's 2.100 grams times 100. So cancel the ml, cancel the milli equivalent, and also cancel the grams. The percent purity for our aspirin here is, again, 10 times 1.1 times 0.09 divided by, diretsuhin ko lang ha, divided by 2.1 times 100. The answer is 47.14%. 47.14%. Okay? So that's how we do the computation for a substance, for a drug, or for a chemical substance that requires blank titration in the process of obtaining the percent purity. So in this case, the sample here is aspirin, and yung content niya na aspirin is just 47.14%. Okay? Do you have questions or clarifications? Anyone? Wala pa akong tana. Okay, so it's 4:23. I cannot finish this one. I will continue this one next meeting, and this will be your assignment. Oo, gihapon niyo siya tong sa quiz. Asa? Kani? Same formula. Yung sa quiz, ang formula nun is for indirect titration alone. Itong ginawa natin sa aspirin is involving blank titration. Blank titration. May blank titration dito. So again, I will continue. Itong 10 ml, hindi to kasali sa assignment. I'll be doing this next meeting. Ito lang yung assignment ninyo. What are the complexation and precipitation methods? Give some examples or reactions involving the said methods. And what are the indicators used in both methods? So before we're going to proceed with the next lesson, I think I'll be giving you a quiz about alkalimetry. But before the quiz, I will be doing this one, this part here. Gagawin ko ito before our quiz next meeting. Anything else?